All right, let's jump right into today's breakdown. We're dissecting a literally zero margin for error process, the Letourneau pre-rig move brake popping procedure. Look, when you're jacking thousands of tons of steel over the open ocean, the brakes holding that weight are your only insurance against a catastrophic failure. So we're going to walk step by step through executing this procedure, how to secure the rig properly, and exactly how to troubleshoot when the heavy machinery decides to fight back.
Here's our game plan for this walkthrough. We'll start with the non-negotiables for preparation and safety, move right into the unbreakable one-plug rule, cover the physical execution of the pop, lock it down in the securing phase, and finally, run through the contingency plans for troubleshooting hub failures.
Now, the primary tool we're working with here is actually super fascinating in its specificity. We call it the brake popper. Before anyone even touches a wrench, you need to understand what this thing actually does. Think of it almost like a highly calibrated defibrillator for the rig's hardware. It's a specialized device that feeds controlled electrical pulses into the system. And while we're running this specific test, it completely replaces the normal rig power. Its one and only job is to momentarily release the brake so we can physically verify that the mechanics are working perfectly.
Okay, let's get into the setup. First things first, setting the stage safely.
This number right here, this is your absolute constraint, 24 hours. This entire brake popping procedure absolutely must be completed within a strict 24-hour window right before jacking. You can't just knock this out a week in advance and call it good. You have to plan your entire work schedule so this testing aligns perfectly with the actual rig move.
And to hit that tight 24-hour mark, you've got to run through the pre-task requirements. Imagine we're standing right there at the jackhouse. Your job safety analysis, completed and signed. Supervisor, notified. Full PPE, on. And we've confirmed we are definitively working on a Letourneau system. But here is the absolutely crucial takeaway. There must be exactly 2 people present. This is a mandatory, non-negotiable dynamic. You need one person strictly laser-focused on observing the brake hub, and the other person completely dedicated to operating the brake popper.
Which brings us to our next phase, and honestly, the unbreakable law of engagement for this whole operation.
Treat this rule like a giant flashing stop sign in your workflow. One plug at a time. No exceptions, period. You're going to be handling these Joy-style electrical plugs on the motor brake assembly, and the absolute second you disconnect a brake, it is completely outside of its normal protected state. So you have to work sequentially, one motor at a time, making sure it is fully reconnected before you ever even think about touching the next one. Oh, and when you unlock the locking collar from the outer magnet ring bracket, do not yank it. Don't force it. Treat the hardware with respect. These connectors need to survive years of brutal offshore conditions.
All right, with the rules established, let's get into the kinetic climax of the whole procedure, actually executing the brake pop.
We break this down into 4 very precise steps. Step 1, disconnect only one joy plug. We just talked about that. Step 2, you connect your brake popper's joy plug right to the motor brake head assembly. Now listen, crucially, the switch on the popper absolutely must be in the off position before you make that connection. Step 3, the operator rapidly flicks the popper on and off while the observer watches the hub like a hawk. What happens is the electromagnet activates, releases the disc pack, and all that stored torque causes the hub to momentarily rotate. Then step 4, reconnect and secure. But let's actually zoom in on the physics of that third step for a second. Half a turn. That's it. This specific limit is the literal dividing line between a successful test and a highly dangerous mechanical failure. When that brake momentarily releases, the motor is naturally going to try to unwind. You have to enforce a half-turn maximum limit. If you see that motor continue to unwind past that half-turn mark, you stop immediately. Release the popper to reset the brake and investigate what's going wrong before you take another step. So you might be wondering, what does a good result actually look like? A successful test is just a small rotation, a quarter turn or less that stops cleanly and sharply. That precise kinetic movement is exactly what confirms the brake is electrically and mechanically ready for the ocean.
Okay, so you got a clean pop. Are we done? Not quite. We have to lock it down.
I always find it amazing how the smallest components matter so much in heavy industry. Once you disconnect the popper and reconnect that original joy plug, you have to secure the 2 halves together with a simple cable tie wrap. I know it sounds basic, but think about the immense, violent physical forces and vibrations traveling through a rig while it's jacking. An unrestrained connector can incredibly easily vibrate loose. That humble little tie wrap, that's your vital insurance policy against a brake suddenly losing electrical control right in the middle of a jack. Lock it down.
But we all know things don't always go according to plan. So let's talk contingencies and troubleshooting.
What if you hit the popper and the hub absolutely refuses to rotate? No quarter turn, no movement at all, nothing. Well, you're immediately facing one of two pretty grim realities. Either the brakes are mechanically stuck tight, or the motor and gear unit have absolutely zero torque applied to them. The tricky part, both scenarios require the exact same diagnostic response to figure out which one it is. Now, before you start ripping things apart, heed this warning. Removing the brake assembly takes 2 people. It is extremely heavy, and it is heavily spring-loaded. As you disconnect the joy plug and prepare to back out the 3 cap screws, holding the brake assembly to the motor end bell, you have to exercise strict physical restraint. Sudden spring release is a very real, very physical danger here. You have to respect the physics of the machinery. Once it's safely off, you begin the troubleshooting cascade. You're going to carefully remove the brake discs one at a time using a screwdriver, maintaining that restraint. There are exactly 6 rotating and 7 stationary discs in there. Whatever you do, maintain the exact order of removal. Next, inspect every single one of those discs for excessive wear or cracking, replacing them if needed. Then, assuming the motor didn't suddenly unwind on you during the disc removal, you take a torque wrench to the motor hub and try to manually rotate it.
And this is where we hit a clear fork in the road for your diagnosis. If that hub rotates freely when you apply the wrench, it means there's no torque applied. Good news is, you can fix this by proceeding directly to the standard retorquing procedure. However, if that motor is frozen solid or has excessive drag, you've got a much larger gear unit problem on your hands. That requires a full examination, and you must escalate the situation immediately to your supervisor.
Now, if you are cleared to proceed with reassembly, precision is everything. You have to clean out the stationary disc support slots. You absolutely must reinstall the disc brakes in the exact same order they came out. Then, reinstall the brake assembly carefully. And finally, you have to dial in the air gaps to exactly 0.070 inches. Which ultimately brings us to the core of why we do all of this. Why are we so militant about the one-plug rule, the half-turn limit, the exact ordering of the discs? Because, as the saying goes, a motor with no torque is a motor that is not holding its share of the rig weight. If even one untested brake fails during a massive rig move, the cascade effect could cost millions of dollars, or worse, lives. So I'll leave you with this question. Next time you're gearing up for a move, are you absolutely 100% certain that every single motor on your rig is actually pulling its weight? Something to think about. Catch you next time.